Audio Jungle. Audio Jungle.
Hello everyone, myself Narendra Singh Maurya. Hope you all are doing well, right? So last session we had seen that solution of GATE 2022 for aircraft performance, and now we'll do today GATE 2021, right? All the performance problem solution we have to see here. All right. Now, so check it. This is the problem number 12, okay? And in this problem, see, let VTAS, what is VTAS? It's a true air speed. VTAS, it is nothing but true air speed, okay? True air speed. Be the true air speed of an aircraft flying at a certain altitude, means this speed will be taken at an altitude, okay? Obviously, I will give the graph also for this particular, and certainly where the density of air at this altitude, density of air is given rho, and VEAS, what is VEAS? See that name, it is nothing but equivalent, okay? It is nothing but equivalent airspeed, equivalent airspeed. All right. If rho naught is the density, and obviously this equivalent airspeed is always will be measured at sea level, okay? At sea level, and that density at sea level it is given rho naught. So hope you understood, means to airspeed it is given, and that is nothing but true airspeed and equivalent airspeed. True airspeed is always uh, will be calculated at any particular altitudes, and that density will be given at that particular altitude, okay? And equivalent airspeed always will be calculated at sea level, and obviously sea level density is also given. Now we have to develop one relation between true airspeed and equivalent airspeed. That relation you have to develop. Hope you all understood the questions. And they are saying like, okay, what will be the relation in terms of density? So that relation, what the relation they are asking? They are asking here true air speed and equivalent air speed, that ratio they are asking in terms of density, okay? So these all value here it is given. Which one is correct answer? We don't know. We have to calculate that. All right. Now, so we'll see. We'll find. So first of all, we'll develop the relation between true airspeed and equivalent airspeed. As I said, like that graph I will give for the all type of speed, okay, like indicated airspeed, calibrated airspeed, all right, equivalent airspeed and true airspeed. So you will understand, it's very easy. All right, now see. So check first, speed is nothing but indicated airspeed, okay? And then you will have, after the correction you will have a calibrated airspeed. Again you have to correct this calibrated airspeed, so you will get equivalent airspeed, okay? And again you have to check some correction, then you may get true airspeed. All right, so these are the different airspeed. So we'll have to see that how it will be related to each other. So indicated airspeed, if you correct instrument error, if you correct instrument error and position error, okay, then you will get calibrated airspeed. And again the in calibrated airspeed, again you have to correct compressibility error, okay? Huh? That's sea level. then you will get equivalent airspeed. Again you have to check altitude error, so you will get the a true airspeed. So how, so like how both are related to each other. So I'll go with this simple diagram. Suppose this is what sea level, okay, and this is what one altitude. All right, at this altitude density is rho, and at sea level density is what, rho naught. Okay, so whatever the dynamic pressure for the sea level and altitude, that dynamic pressure will be same, and this dynamic pressure, okay, this dynamic pressure will be same here. Dynamic pressure will be same here. So what is the dynamic pressure? What is the dynamic pressure? You all know it is nothing but half rho v square. So you have to write dynamic pressure for sea level and dynamic pressure for that particular altitude. Okay, it suppose this altitude is what, at distance h. All right, so both dynamic pressure you have to equate because it will be equal. All right, so now dynamic pressure for the sea level you have to write, so it will be half rho v, and sea level, if you write sea level, so sea level density will be rho naught. I think it is given, check that notation we have to follow. Rho naught is given, so no need to write sea level, it is given rho naught. All right, it is given rho naught, so it is nothing but rho naught. All right, it's rho naught, and if you take sea level correction, then you will get equivalent air speed. So this is equivalent air speed equal to dynamic pressure will be equal, as I mentioned, and at that particular altitude what is the density? It is nothing but rho, and at that altitude what is the density? If you correct the altitude errors, then you will get true air speed square. Okay, what ratio they are asking here? They are asking true air speed to equivalent air speed. So we will write true air speed to equivalent air speed. Check, all value will be cancelled out like 1 by 2, that value will be cancelled out. True air speed divided by equivalent air speed, you may get rho naught divided by rho in root. Yes or no? So check which option is correct. Rho naught by rho in root, this is option C. All right, so this is the correct answer. So what is the correct answer for this problem number 12? Correct answer is C. All right, so this is the basic atmosphere chapter. If you go for it like a aircraft performance and design subject, or introduction to aeronautics, atmosphere chapter is given, right? So in that all the types of the speeds it is given, so you can follow that textbook. Otherwise I have in my lecture sessions it is explained well, so very soon you will get that lectures also. It will be available in that playlist. All right, okay, now this is the next problem. This is the problem number 23. All right, this is also gate 2021, problem number 23. All right, now see, so if you read this problem, what they have given, a jet aircraft, okay, jet aircraft has the following specification: wing loading 1800 Newton per meter square, wing area 30 meter square, drag polar CD is equal to CD naught plus KCL square, so 0.02 plus 0.04 CL square, and CL max also given, that is 1.6. Take density of air at sea level as 1.225 kg per meter cube. All right, these are the given data, and what they are asking, the speed at which the aircraft achieves maximum endurance in a steady and level flight at sea level. All right, we have to write that answer of the speeds in meter per second. You always need to check the units of, okay, and round off two decimal places. So this is the fill in the blank. There is no negative marks for this, but you during the calculation you have to be more careful, because any mistakes you may not able to find that answer it is right or wrong, whatever you are filling. Okay, so this is the fill in the blank problems. So obviously there will not be negative marks, but your calculation should be correct, because that answer will be in range. All right, so whatever the answer you are filling, it should be in that particular range, otherwise you will get 0 marks. So that you must know. Anyway, so if you write the given data here, check given data. All right, so wing loading. What is the wing loading first of all? So what is the weight of the aircraft divided by the plane form area? That is called wing loading, and it is denoted by small w. That value it is given. Obviously that unit also you can check, Newton per meter square means weight divided by area. So this is called wing loading. Okay, now wing area is also separately it is given, that is S, how much, 30 meter square it is given. And drag polar, as in last lecture I explained what is a drag polar. So drag polar is basically you need to write that parasite drag and induced drag, that uh, one relation will be developed which is called drag polar. Okay, so CD naught parasite drag, and this is about CDI induced drag. So this relation if you represent with the equation called drag polar, so this CD naught plus CDI also will be given KCL square. So this is the exact format, and here in this problem CD naught is given 0.02, okay, plus K is given 0.04 CL square. This is the drag polar. Okay, drag polar. All right, CL max, here I will write CL max is also given, how much it is, 1.6. So basically CL max sometimes it will be given so that you can understand what is the stall speed. Stall speed is the minimum speed required for the aircraft to sustain the steady level flight. All right, so that is the CL max here it is given, and sea level density rho naught you can say, or rho SL is given, how much, 1.225 kg per meter cube. This value they have given. All right, now so the speed at which the aircraft achieves maximum endurance. So like endurance and range, it that formula is what depends on the types of the aircraft. Okay, like for the jet aircraft and for the propeller aircraft or piston prop aircraft, for both type of the aircraft, that endurance formula and range formula will be given separately. Okay, so here it is very important, like whatever the aircraft here it is given, so for that particular aircraft we need to write the formula for the endurance. But what is the aircraft here, jet aircraft, so for this jet aircraft we have endurance formula. Okay, similarly, for the propeller aircraft or piston prop aircraft, that for that aircraft endurance formula is what given. So it is very important point I am saying, like for both type of aircraft, two different formula will be given. I mean endurance formula will not be same for jet aircraft and for propeller aircraft. That is my point. Hope you understood. Similarly, range formula will not be same for jet aircraft and piston prop aircraft. All right, so it is very important to know. That's the reason I'm giving a stress on this particular point. So here it is jet aircraft, and for this jet aircraft what is the endurance formula? So endurance formula is nothing but, it is denoted by E. Okay, and here it is nothing but 1 upon CT CL by CD. CL by CD. CL means lift coefficient, CD means drag coefficient, ln, okay, w naught means initial weight divided by w final after burning of the fuel, what is the final weight. All right, anyway, so here they are asking uh, what they are asking maximum endurance. So what is the maximum endurance if you maximize this? So E max 1 upon CT. CT is the uh, thrust specific fuel consumptions, right? Thrust specific fuel consumption, this will be a constant value. Anyway, so here if you maximize this, so CL by CD will be maximum in this case ln W naught by W. Okay, fuel. Anyway, so what is this term CL by CD? This CL by CD max will also be known as minimum drag condition. This is called minimum drag condition. All right. Anyway, so you have to apply, I mean, if you want to calculate maximum endurance, then you have to apply minimum drag condition. That is the conclusion we got here. Okay, so if you go for the uh, calculation of the speed at which maximum endurance occurs, it means for maximum endurance, if you are going to calculate the speed value, so that condition you should know. What is the maximum endurance condition? That aircraft should fly, for maximum endurance, that aircraft should fly with minimum drag condition, and at that minimum drag condition, what will be the speed? That is your calculation. So you can write speed at, you just write this sentence, speed at maximum endurance, or you can write, the meaning will be same, you can understand easily, speed at minimum drag condition. Because both statements are the same thing. So that speed at minimum drag condition, it will be denoted by VMD. Okay, it will be denoted by VMD. This is the minimum drag velocity. It is called minimum drag velocity. Okay, it is called minimum drag velocity. So you know very well what is the generic formula for the steady level formula. L is equal to W is equal to half rho V square S into CL. Okay. Now you can write this V is equal to 2W because weight is given for this particular problem. Weight, or you can say wing loading, is given. So 2W divided by rho S into CL. This value is given. Okay, if it is the minimum drag condition, VMD, weight will be constant, density, it is sea level, so density will be constant, obviously area will be constant, no doubt. So what will change? If it is minimum drag velocity, so this lift coefficient will also be minimum drag lift coefficients. All right, now this one you can write simply 2 W by S. I am taking separately. Why? Because this is the wing loading and it is given separately in the problems. So rho naught CLMD. This will be the value. All right. Now we'll go for this. VW is equal to 2 W by S rho naught CLMD. Now this is your concern, CLMD. So what is the CLMD? It is nothing but lift coefficient at minimum drag, right? At minimum drag. Yes or no? Now, so if drag polar is given, CD is equal to CD naught plus KCL square. So if you want to calculate what is the CLMD, minimum drag lift coefficient, so it will be CD naught by K. Okay. You can compare here. What is the CD naught? Check. What is the CD naught here in this problem? That value is given. It is nothing but CD naught is 0.02 and K is 0.04. Simply you can write this. Okay. So it is nothing but 0.02 divided by 0.04. Okay. You can write this value. How much you may get? You can calculate this value. You will get 0.707. All right. Similarly, CDMD you can write. You keep this CLMD value here. So CDMD you may get, and CDMD you may get, that will be 2 CD naught. So 2 into 0.02, it is nothing but 0.04. This is the CD naught. CDMD if it is required. Okay, but actually you need CLMD, no need to calculate, but here I have calculated, so you can uh, use this data if it is required, but here it is not required obviously. Now you can calculate VMD, so I will write all the value here. See, this is the VMD. 2 into wing loading is given, how much it is? It is nothing but 1800 Newton per meter square. All right, and area is given 30 meter square. So now area we not required, because you are going to directly write wing loading value. So that is 1800. Okay, rho naught is given, density how much it is? 1.225. See this value, it is 1.225 is given. You write here 1.225 into CLMD is 0.707. You just calculate this value. If you do this calculation, how much you may get? It will be 64.47. Okay, this is your answer. So here you can write 64, this value will be 64.47. Okay. Right, so this is the solution for this problem. Up to 2 digit you have tried. Okay, any doubts you may get, then you write comment below, so I will answer for that. Okay, anyway, this is the next problem. Here it is given. See, which of the following statements is are true? So this is the multiple select question. All right, this is called multiple select question. This is called multiple select question, MSQ. So more than one option will be correct, just like a MCQ, multiple choice question. So only one answer will be correct in MCQ, but MSQ means multiple select questions, more than one options will be correct. So you have to take care of it. Okay, once you solve the problems, multiple select question kind of problem, if you solve, then you fix in your mind more than one options will be correct, so you take care of it. Anyway, which of the following statements are true? Service ceiling is higher than absolute ceiling for a piston propeller aircraft. No, this is completely wrong. Absolute ceiling is always greater than service ceiling. All right. For a given aircraft, the stall speed increases with increase in altitude. Yes, what is the stall speed? I told you it is the minimum speed. 2W divided by rho S into CL max. Okay, this is the stall speed. So CL max is the one constant data, W weight is the constant data. Okay, S is the planeform area of the wing, it is constant data, or you can say wing loading, W by S is the wing loading, this is the constant data. All right, so basically this is nothing but 1 upon rho. In root I will write. So density, whatever the density, if you change the altitude, if you go from sea level to upward direction, altitude increases, so density will be decreasing, that you know. If density will be decreasing, so this value will be increasing. What here it is given? For a given aircraft, the stall speed increases with increasing in altitude. So it means this is the correct statement, because if you are increasing altitude, so density will be decreasing. If density will be decreasing, so this value will be increasing. Yes or no? You can relate this. So it means B option is correct. All right. Everything else remaining the same, a tailwind increases the range of an aircraft. That is also correct. Huh? Range and endurance. So it was explained well, like in my subjects, two types of wind you may get. Okay. Suppose this is the aircraft. Okay. So this is called headwind and this is called tailwind. This is called tailwind and this is called headwind. Okay, everything else remaining the same. A tailwind increases the range of an aircraft. So if it is tailwind, so tailwind will increase the range of an aircraft. That is the correct statement. All right, this tailwind will increase the range. If it is headwind, it will decrease, plus minus both. So option C is also correct. Now we'll go for option D. For a jet aircraft constrained to fly at constant altitudes, okay, there exists an altitudes where its range is maximum, and that is true, because whatever the aircraft you have, and that altitude will be almost fixed for that particular aircraft. And why it is fixed? Because at that particular altitudes, for the given fuel amount, that range will be maximum. That range will be maximum. That's the reason you are flying at that particular altitudes. That is the one advantage. So yes, this is true. So option D is also true. So what is your correct answer here? I will write correct answer is B, C and D. All three. All three is correct answer. Alright. Now we'll go for next. Again, for any problems, whatever solution I'm giving, if anywhere you may have doubt or any doubt comes in your mind, then immediately you can comment. So I will reply for that particular. Alright. Alright. Now we'll go for the next problem. Alright. This is problem number 41. Again, this is GATE. This is GATE 2021. Okay. All right. Read this problem. A finite wing of elliptical plane form with aspect ratio 10, whose section is symmetric airfoil, is placed in a uniform flow at 5-degree angle of attack. The induced drag coefficient for the wing, round up to 3 decimals places they are asked. Okay. So now see, finite wing of elliptical plane form. So that wing, whatever the wing we have, it is elliptical. If it is elliptical, then first thing comes in your mind, that is Ostwald efficiency. For elliptical wing, Ostwald efficiency will be 1. Okay, this is the one thing. That's the reason they have given this statement. Elliptical plane form they have mentioned, so that you can understand Ostwald efficiency factor E is equal to, it will be 1. For rectangular wing, for delta wing, for swept back wing, that value will be less than 1. But for elliptical wing, E is equal to 1. It means Ostwald efficiency will be 1. Alright. Anyway, aspect ratio they have given. Okay, they have given data. Aspect ratio they have given to you. How much it is? It is 10. So you know very well what is the aspect ratio formula. It is nothing but span square divided by plane form area. Aspect ratio is equal to span square divided by plane form area. So directly they have given to you that aspect ratio, so no need to calculate. Sometimes they may give span and sometimes they may give plane form area, so that you can calculate aspect ratio. So aspect ratio here it is given directly 10. All right. And that wing, elliptical plane form wing you have, but what is the section of that elliptical plane form? That airfoil is what? Symmetric airfoil used in that finite wing. Okay, so symmetric airfoil is used here. Need to relate this. Symmetric airfoil. So if symmetric airfoil is given, then what comes in your mind? Automatically CL is what? 2 pi alpha. This is derived for the asymmetric airfoil. Okay, symmetric airfoil, or you can say thin airfoil, both, because generic formula for the CL is 2 pi sin alpha. But if it is thin airfoil or symmetric airfoil, and angle of attack is what? Very less. Okay, then this sin alpha, for very small angle of attack, you can write alpha. Sin alpha you can write alpha. Hence CL is equal to 2 pi alpha you may have. So for this reason they have given that word symmetric airfoil, so that you can understand why this symmetric airfoil are used, because they want to use this CL is equal to 2 pi alpha formula somewhere if it is required. All right. And here that alpha is given, how much it is? Remember, this is degree, 5 degrees given. Angle of attack. Angle of attack, it is denoted by alpha. So I will write angle of attack, which is denoted by alpha, and that is given 5 degree. Induced drag coefficient for the wing. What is the induced drag coefficient? Yes. Induced drag coefficient, it is denoted by CDI. Induced drag, called induced drag coefficient. CDI. What is the formula for this? Yes, formula is CL square upon pi EAR. This is the formula. Hope you understood why all the data they have given to you. Because CDI they are asking, and in CDI formula if you check, CDI is equal to CL square divided by pi EAR. Okay, for elliptical wing you know, for elliptical wing is equal to 1, hence CDI is equal to CL square divided by pi AR. Okay. Remember, CL value is what? For symmetric airfoil, it is 2 pi alpha. But alpha is what? In degree. Alpha is what? In degree. So you need to convert it into radian. Then only you will able to solve. So alpha is what given in degree, but you have to convert it into radian. So if you convert into radian, then you have to multiply by pi divided by 180. If you do that, then you may get some approximate value 0.0872. You need to check it. Okay, you need to check this value. All right. 0.0872 approximate. So this is the alpha. Now it is in radian. Okay, it is in radian. Now this radian value only you can use in this formula. So CL will be 2 pi alpha square divided by pi a r. So it is nothing but 2 pi, okay, into what is the alpha in radian? 0.0872. 0.08, 0.0872 divided by pi into AR. Aspect ratio, how much it is given? 10. See, aspect ratio they have given 10. Alright, this value is what? Square term. You now calculate this. Okay, if you do this calculation, then how much you may get? Approximate. Okay, approximate you may get 0.00955. This is the approximate value you may get. Okay, all right. So okay, let me check what value. Round up to 3 decimal places they are asking. Okay, round up to 3 decimal places they are asking. So 3 decimal places, so approximate you can write 0.009. So this will be the answer. 0.009 if you fill, it will be accepted. This will also be accepted. Actually that value is what? 0.00955, but if you fill 0.009 also, it will be accepted. Round up 3 decimal places. Hope you understood. All right, now we'll go for next problem here. Check, this is also GATE 2021. Okay, problem number 54. We'll read this problem. A jet aircraft weight is given 10,000 kg. So that value I will write first. Mass, unit kg is given, so it is mass 10,000 kg is given. All right. Has an elliptical wing with span. Elliptical wing means host wall efficiency will be 1. This is the given data here. Okay, has an elliptical wing with a span of 10 meter. Span of 10 meter is given, and area is given how much? 30 meter square. The CD node for the aircraft is given how much? 0.025. The maximum speed of the aircraft in a steady and level flight at sea level is given. Maximum speed they have given V max 100 meter per second. The density, okay, this is the sea level maximum velocity. Density at sea level also given how much? Sea level, so it is 1.225 kg per meter cube, and take g value is also given, gravitational acceleration 10 meter per second square. The maximum thrust developed by the engine at sea level they are asking. It's very clear problem. A jet aircraft weighing 10,000 kg has an elliptical wing with a span of 10 meter and area 30 meter square. The CD naught for the aircraft is 0.025. The maximum speed of the aircraft in steady and level flight at sea level is 100 meter per second. All right, maximum speed they have given. The density of air at sea level is 1.225 kg per meter cube, and take g is equal to 10 meter per second square. Okay, the maximum thrust developed by the engine. Okay, so this is the problem, guys. All right, so as per given data, CD naught they have given to you, and host wall efficiency for elliptical wing you know is equal to 1. Span they have given to you. All right, so we'll proceed this problem. Now check. So first of all, we should know that concept, that where and how you will get maximum velocity. What is the concept for this, right? So it's very simple. If you draw the plot, that plot is nothing but thrust versus velocity, and velocity what? V infinity. I will draw here, and this is what? Thrust T. So because it is the jet aircraft, so obviously for jet aircraft, you know, thrust is, you are considering it is almost constant. So I'm taking, this is what? Thrust. All right, this is the thrust. Okay, and this is the thrust, but this thrust will be available thrust. That's the reason I said for jet engine aircraft, available thrust is what you are taking constant, and I am considering this is the maximum thrust available. This is the maximum thrust available for that particular jet engine, available thrust. Now required thrust graph will be like this, you know, well, it is already explained in your like a BTech level, if you remember this, because this is the solution classes. Okay, going on, I'm giving the solution. Yes, very soon I will upload the lecture classes also. Here it is solution, so very limited things I'm telling to you, because I'm considering you guys have enough prepared for GATE 2023 now, and for to help you out, I'm giving the solution for that previous year problems. All right, but yes, after this solutions and all, I will give the lectures for all the subjects. So whatever the problem you may get, you can watch my lectures for particular subjects, so everything will be revised for you guys. Anyway, so this is the available thrust and this is the required thrust. It will be going like this. So this is the velocity, free stream velocity. So available thrust and required thrust, where it will cut, it will be two places. It will be two places. So this place will be called as, because this is the velocity, so obviously here velocity will be 0 at this origin. So here whatever the velocity you may get, it will be minimum, and whatever the velocity you may get, maximum. So that's the reason I told you, first I will explain what is the mean of the maximum velocity. So wherever available thrust and required thrust will be cutting to each other, that plots, okay, cutting to each other. So I will write here, this is the TA. available thrust of jet engine, Ta of jet engine, all right, and Tr is the required thrust of jet engine. But for minimum velocity and maximum velocity, what mathematical relation you are getting for minimum and maximum velocity from the plot? You can check at both places it is cutting to each other, so any curve will be intersecting to each other at one particular place, so at that particular place that value will be equal, means available thrust is equal to required thrust. That's the mean of it. I hope you understood now. That's the mean of it. Okay. Yes. Now this curve part is what? Okay. Okay. Now I will give this is the graphical representation to like how to understand maximum velocity and all. Now I will give the relation between the velocity and a thrust. So V infinity is equal to T by W. I will explain each and everything. W by S, okay, plus minus W by S, okay, T by W minus 4 CD naught K divided by rho sea level density CD naught to whole root. Okay, so this is plus. Plus indicates maximum, negative indicates minimum. So here they have given plus maximum velocity, so you can write V infinity as you can write V max is equal to thrust. This is the required thrust, okay, this is required thrust, but yes, if you are talking maximum velocity or minimum velocity, then this required thrust you can consider as a available thrust. All right, here what they are asking in the problem, the maximum thrust developed by the engine means maximum thrust available in the engine. That's the mean of it. Develop or available meaning is same. They are not saying required. Even though available or required both will be same, so any statement they can use, no problem. So Ta max, because you are saying maximum velocity, so here whatever the thrust you may have, that will be maximum W by S. Now we will take max plus, because maximum velocity, so we will take plus W by S Ta max divided by W square minus 4 CD naught K, and it will be rho naught or infinity, or rho naught meaning is same, means sea level density CD naught whole root. Okay, check what quantity they have given to you, what they have not. CD naught they have given to you, K you need to calculate. Weight of the engine, weight of the aircraft they have given to you, mass is given, so weight you can calculate. S area of the wing is given. Thrust available you have to calculate. V maximum is given. This is given. Check. Given. Given, no? S it is given. Given, these data are given. What they have not given? Calculate. We have to calculate this. And K you can calculate this because data is given. I will write this K. I told you this K is what? It is nothing but, if you check the drag polar equation, hmm, what is the drag polar? It is nothing but CD is equal to CD naught plus KCl square. This is the one constant in induced drag. And what is this constant value? 1 upon pi E AR. This is the value. Okay. What is the aspect ratio? B square by S. Hmm? Span square divided by area of the wing. Check all the value. Span is given or not? What is the span? 10 meter. What is the area? 30. So I can write this value. How much you may get? 10 square divided by 30. How much you may get? It is nothing but 3.33, I think. 100 divided by 30. Okay. This is the value. You can get K now. 1 upon pi. E is, because it is the elliptical wing in problem it is mentioned. So E aspect ratio 3.33. What will be the K value? It is 0.095. So now all the value will be given to you here. Check. K is given now. Given. CD naught is given. W you can, obviously it is given. You can calculate mg. G is given. Mass is given. Everything is given. V max is given. Now you solve this. Once you solve, so you may get that value. How much you may get? You keep all the value. Okay. Keep all the value. Not Vmax. Vmax is given to you. So we need to write Tmax. All right. We need to write Tmax. Yes or no? So approximate you may get 9772. This is the value. Okay. You need to check. This is your answer. Need to fill or what? 9772.05 Newton. It's Newton. Okay. Need to write this unit. It's Newton. 9.772. Let me check here. They are asking Newton or kilonewton. Newton. So you need to write only directly that value. You need copy and paste 977 2 point how 2 decimals. So 2.05. This is your answer. Hope you understood. Now you may ask like, sir, how we can remember this formula, long formula. So that is the one thing, how we can remember. So this is the one derivation, and out of that result of that derivation is very important. Many times I explain in my class also, regular classes. Like I said, definitely they can ask question any times from this. So yes, 2021 they had asked directly based on this formula. So this is the one solution I have given to you for this particular. But yes, this one is what little bit lengthy, because by that virtual calculator, gate virtual calculator, is not possible to calculate this value, long value, from the calculator. It is quite difficult. So another shortcut also available. So you write comment on that below. You have to write the comments. If you want, then again I will solve with another way also this problem. But yes, this is the perfect form solution for this particular problem. So I hope, like, whatever the problems, like 4 5 problems uh, it is asked in like gate 2021. So all the problems almost I have covered. And if any problems left, then you can write comment, question number or something. And any like any problem you are getting, whatever the solution I have given, or might be you are not understanding that, right? Any doubts you have, so you can write comment below. All right, so I will reply, surely I will reply it. So okay, now we'll stop here. Okay, thank you all, thank you so much.